So in terms of design considerations, we've looked at some of these already. You know, the installation that's available, climate and weather, shading and latitude. We looked yesterday at some path diagrams with the altitude and azimuth. You know, and we've done all of this already, so this is something you should be familiar with. Now, in terms of thinking about the orientation of collectors, obviously, if you tilt it towards the sun, you increase the amount of direct radiation, and because you're exposing that cell to a smaller proportion of the sky, you know, there's less indirect radiation. And so when you think about, for example, thin film technologies that do quite well with indirect radiation, you know, mounting them horizontally on large building roofs might be a more viable option. There's also this really interesting study that's come out of Glyndwr University, and what they found in Germany is that they've got such a high proportion of cells that are facing south, and obviously Germany's got great penetration of PV because they've been sort of market leaders and they've been there from the start. You know, a fantastic proportion of their electricity is produced from PV, and obviously everyone wants to optimise their own installation to get the most amount of light possible. So if they can make it face south, that's obviously considered the best option. But when you start getting high penetrations of PV, the challenge then becomes what to do about the spike of energy that you get at lunchtime when the sun is high in the sky, sort of noontime. And obviously that's not so much a challenge that the homeowners are worried about, because for them they're just interested in earning the best amount of tariff possible. And we're going to look at storage technologies and some other things that could ameliorate this sort of problem. But they're saying actually we should be considering more east-west installations. They might be slightly less efficient, but we've already discussed the issues about sort of producing power when you actually need to generate it. And one of the technologies that we're looking at a little bit later is bifacial solar cells, which is where you've got a PV that's encapsulated between two sheets of glass, so it can capture light from this side and that side. And the great thing about bifacial cells is that if you mount them vertically in an east-west configuration, you know, you can capture the light from the east and also from the west. So, you know, it's interesting things to think about when considering design solutions for buildings. And also, even if they're not sort of free to the air, even if you've got something, you know, say they're on a car park canopy with cars underneath, even the reflective light, you know, they can capture some of that, you know, if you've got a white car parked underneath or whatever. So this is Professor Michael Wallace from Glyndwr University, and saying very similar things to what's already been said in that last little bit. And also, I mean, if you think about places like Cornwall, they're starting to get to the point there where, because the grid is quite weak and because there's already quite a high penetration of PV in Cornwall, you know, the DNOs are starting to say, actually, sorry, we can't accept your good connection for PV. You know, we've got too much already. Whereas maybe if you say, well, actually it's an east-west installation, it's not going to be producing the power at the same time as everyone else with, you know, the south-facing installations, you know, there's a different consideration there. So, bifacial PV cells, just alluding to that there. Cells encapsulated in glass, you've got light that can get to them from both sides, it improves the efficiency of the cell, and also they look quite nice. You know, they're quite an aesthetic thing. If you want a building to look a bit high-tech and you want to make the technology look visible, the great thing is if you've got skylights or whatever that are covered in bifacial PV cells, you can look up and see them and think, oh, it's really pretty. So they're quite useful architecturally as a bit of a device for architects to make buildings sort of green, but also show that green technology you know, really visibly. And there's a couple of pictures here coming up. This one on the left is, I know this is the Centre for Alternative Technology. The one on the right, I'm not quite so sure where that installation is, but you can see where this bit on the left is actually, there's an eating area underneath there with some chairs and tables where people can sit down and you know, have a meal. And what's great here about the use of the bifacial cells is that it's allowing a little bit of light through there. You know, if we covered this with standard PV cells, you know, this would be a really dark area. But at the same time, you don't want to make it a greenhouse. If people are eating their lunch and their sandwiches, you wouldn't want to just put glass there because they'd absolutely bake and roast. And so the great thing is here with the bifacial cells is that you're keeping the water off them in the first place, so the cell is also doubling as a roofing material, so you've got that building integrated saving there. It's allowing a little bit of the light through, making the area below functional in the day without any additional artificial lighting, but you're also generating energy, so there's loads of wins with this sort of technology. And you can see here, I think this is sort of an agricultural barn type area, absolutely covered in bifacial PV. And very similarly, if you covered this with glass or translucent plastic or whatever, this space underneath here will probably get quite hot and maybe be a little bit too bright. Whereas with bifacial PV, you can capture some of the light for energy, allow some of the light to come through. And so this leads on to thinking about other sort of glazed areas and using PVs in skylights. Now, there's another presentation I'm going to squeeze in after this one, which looks at PV technologies for windows and glazing. And so you can see these skylights that are here, you can just about discern a line on them, that they're letting quite a lot of light through, they look almost transparent. And there are some PV technologies which will sort of colour the light, especially sort of dye-sensitised cells. They're semi-transparent, but they're going to colour your light and make a sort of certain tinge to it. But then there's other technologies which people are looking at which allow you to have a window that, to all intents and purposes, is transparent. So we'll review some of those a little bit later. And so, it's one of those things where if it's properly integrated, the BIPV can form part of the actual skylight glass itself, or it might be something that's applied as something that sits over the skylight, perhaps for retrofit. And so it can be either completely opaque cells mounted within a glass matrix so the light gets through in between, or different technologies we're going to look at that can be semi-transparent or see-through. And so the other application for this sort of technology is in a PV canopy. If you're somewhere like California, you've got a lot of sun. If you park your car out in the car park, it's going to be absolutely baking hot when you get in it, and that's going to be quite unpleasant. Luckily, we don't have that problem in St Asaph, so they won't be putting a PV.
Stop the rain line.
Yeah, this is it. Keep your car rust free. They're not going to be putting a PV canopy on that car park anytime soon, I don't think. But yeah, so it provides a bit of solar shading, and also, in terms of the sort of making corporate social responsibility visible, if you're going to start thinking about deploying stuff like electric charging points, the charging point is fairly inconspicuous, but it's a really visual thing if you've then got a whacking great PV canopy that the cars are parked under, and this all feeds into, customers like a little bit of eco bling. Do you know what I mean? It's something that stands out and it's really sort of wearing it on their sleeves. And so, yeah, it's a very simple installation. There's sort of canopy systems that are available. You put the post into the ground, you assemble the system, the PV mounts onto it. This can be cookie cutted out. And then we were talking about dye-sensitised solar cells. We've got an example here in this bus stop, and you can see how this lends a completely different aesthetic. It's allowing some of the light through because of the dyes that are used. You've got this sort of orangey, reddy colour, so that's a different sort of thing. Now thinking about building facades. So we're talking about the faces of buildings. If you think about tower blocks back in the 1960s, they've had real challenges with the failure of the facades of those buildings, where they'd sort of had concrete panels that were hung onto the building with hooks, and those various sort of hooks and fixings that were embedded as part of the concrete. Over time they've started to go rusty, concrete cancer, that sort of thing, and so the facades have started coming away from the building. So there's a real challenge in thinking, okay, if we're going to mount something to a building, we're thinking about the lifetime of the building, we're thinking about the safety of people that are outside the building. I can remember going to a college in Westminster, and because of this failing facade, they literally had to bolt chicken wire and all these sort of studs all over the outside of the old building. It looked absolutely horrendous. Just to retain that facade for safety. So, we've got to think about the mistakes of the past, and if we're going to start putting PVs on building, we need to make sure that's done in a really secure and robust way. And there's a vast range of different commercial systems, that will enable you to achieve this. All sorts of different studs, mountings, flashings, to prevent water ingress. So that there's a real range of kit on the market. And actually, when it's done well, you can do some really interesting things with it. And you can see this sort of system here where, you know, the fixings between panels are quite visible and low key. You know, and stuff here where you've got that facade but it's encapsulated within a sort of framing system, and actually, you know, you can see you've got windows and openings there to allow light into the building as well. You've seen the sort of facade outside as well. And so what you can also do with PV, we've looked at bifacial PV, is provide shading to the occupants as well. You know, if you allow a little bit of the light through, it might be that there's an area behind that building where you want some light through, but not all. Or if you think about brise-soleil on buildings, you know, if you've got very large glazed areas, sometimes there's an externally applied shade, you know, a series of slats or whatever, that will allow the low winter sun to go into the building. So if you think about, you know, passive solar heating, if you've got large glaze areas and the sun's shining through those, the building space inside becomes warm. You know, if we had all the blinds up and by chance it was a really great day outside, this room would start feeling quite hot in the summer. But in the winter you want the solar going because obviously you want as much heat as you can capture. So you can do interesting things with brise-soleil whereby you say, well actually, we'll set these at a certain angle so that when the sun's high in the sky in the summer, we're generating energy, but we're actually blocking that light from coming into the building. But when the sun's that much lower in the winter, actually we really want that light in the building, you know, occupant comfort and all the rest of it, and we're less worried about the PV. And you can see really interesting things. See this we're talking about failed concrete facades. This is a tower block in, I think it's Germany, where you can see the sort of design and the quality of the architecture of the building beforehand. You know, the really sort of 1960s large panel system construction, concrete monstrosities, all the charm of an NCP car park. And, you know, it had these sort of elements outside, very sort of brutalist architecture, bare exposed concrete, not particularly attractive. And as part of the retrofit of the building, they thought, well, okay, we're going to enclose the balconies, we'll put some glaze systems there to make the sort of inside area of the balcony more habitable. And actually, all this horrible concrete, we can cover it up with loads of PV. And actually, you know, now it's not an unattractive building with that retrofit. And so, when we think about the price and the cost comparison of facade materials, you know, there's obviously some sort of quite cheap options for facades, but when you start thinking about PV modules, you know, they're cost competitive with premium cladding materials. If you think about, you know, stone cladding and all the rest of it, you know, PV can be cost competitive with that sort of thing. And just going back to the brise-soleil as well, one more point. This is a school in France, and I think it's, you know, it's important to think about the human considerations of a building, you know, how people actually end up using the building is not always as the architect designed. And this is a brise-soleil school in France, and this hasn't got anything to do with PV, it's just solar shading. But they've put this to provide solar shading, and the architects thought, oh, lovely idea, we'll keep all the kids nice and cool. And the kids have looked at it and thought, wow, that's a great climbing frame. And so in their lunch hour, they're making their way up the solar shading, and obviously that's not what it's designed for. And as a result, you know, all the metal's distorted and the stuff looks really terrible. So as sort of PV designers thinking about integrating PV into buildings, you know, it's important to think, well actually, you know, is it vulnerable there? Could we do it a little bit better? Is it going to get damaged, vandalised? And, you know, it's an interesting case in point. So also thinking about spandrels and parapets as different places to be mounting PV. So spandrels between the floor and the bottom edge of the window. You know, there was a system, I think probably 60s, 50s, quite in vogue, where you'd have sort of like the windows and then infill panels beneath that were sort of, you know, painted red, blue, whatever, and that sort of thing was in vogue for a while. So, you know, you could think about PV as retrofit for that sort of building. And then also, you know, you've got parapets in terms of if you've got balconies, if you've got walkways outside, you can think about post and railing systems but how can you, be generating a bit of energy from that at the same time? Could you put some bifacial PVs there? Can you use PV as providing privacy at the edge of a balcony so that people, can't see you're sitting down, you're eating your meal in your dressing gown and whatever. You don't want people from the road to be able to see you. But you've got the PV providing a bit of privacy at the same time as generating energy. Different ideas there. And so, thinking about the type of materials that we're using, think of the PV as being mutually interchangeable with laminated toughened glass, applications where that would work. The chances are you can also get PV made by someone like Romac to do the same thing.